Welcome back to CryptoZombies, Lesson 2, Chapter 7, Storage versus Memory. In Solidity, there are two places you can store variables, in storage and in memory. Storage refers to variables stored permanently on the blockchain. Memory variables are temporary and are erased between external function calls to your contract. Think of it like your computer's hard disk versus RAM. Most of the time you don't need to use these keywords because Solidity handles them by default. State variables, variables declared outside of functions, are by default storage and written permanently to the blockchain, while variables declared inside functions are memory and will disappear when the function call ends. However, there are times when you do need to use these keywords, namely when dealing with structs and arrays within functions. We have this contract, sandwich factory. It contains this struct called sandwich, which has a name and a status, which are both strings. We have this array here that is declared sandwich. It is a sandwich array called sandwiches. The function is eat sandwich. It takes in a uint called index. It is public. Here we say sandwich called mySandwich is assigned sandwiches, and then the index that was passed in. Seems pretty straightforward, but Solidity will give you a warning telling you that you should explicitly declare storage or memory here. So instead, you should declare with the storage keyword like sandwich, storage mySandwich is assigned sandwiches and that index. In which case, mySandwich is a pointer to sandwiches and then that specific index. So that's a specific sandwich in storage. And mySandwich.status assigned eaten, this will permanently change sandwiches and that index or that specific sandwich on the blockchain. If you just want to copy, you can use memory, sandwich memory, another sandwich, and we assign to it sandwiches that index plus 1, in which case another sandwich will simply be a copy of the data in memory. And another sandwich.status is assigned eaten will just modify the temporary variable and have no effect on sandwiches index plus 1. But you can do this. Sandwiches index plus 1 and assign to it another sandwich if you want to copy the changes back into blockchain storage. So don't worry if you don't fully understand when to use which one yet. Throughout this tutorial, we'll tell you when to use storage and when to use memory. And the Solidity compiler will also give you warnings to let you know when you should be using one of these keywords. For now, it's enough to understand that there are cases where you'll need to explicitly declare storage or memory. Put it to the test. It's time to give our zombies the ability to feed and multiply. When a zombie feeds on some other life form, its DNA will combine with the other life form's DNA to create a new zombie. 1. Create a function called feedAndMultiply. It will take two parameters, zombie ID, a uint, and target DNA, also a uint. This function should be public. So first, let's do that. Go here. We're creating a function called feedAndMultiply. It will take two parameters, uint zombie ID and uint target DNA. This function should be public. So public. And that is the first part. Second, we want to let someone else feed using our zombie. So first, let's make sure we own this zombie. Add a require statement to make sure message sender is equal to this zombie owner, similar to how we did in the create random zombie function. So within here, we just want to require message sender to equal zombie to owner, and then that zombie ID that is passed in. What is the third thing? No, again, because our answer checker is primitive, it's expecting message sender to come first and will mark it wrong if you switch the order. But normally when you're coding, you can use whichever order you prefer. Both are correct. 3. We're going to need to get the zombie's DNA. So the next thing our function should do is declare a local zombie named myZombie, which will be a storage pointer. Set this variable to be equal to index zombie ID in our zombies array. So here we're declaring a local zombie named myZombie. So we're able to do that because we are borrowing from our other file. So we're doing storage here, and we're calling it myZombie and assigning to it zombies and then that zombie ID. Semicolon. You should have 4 lines of code so far, including the line with the closing right there. So 1, 2, 3, 4. We'll continue fleshing out this function in the next chapter. So that should be what they're asking for. Let us run that. And we did pass. The main thing to take from this, since a lot of it here got kind of convoluted, like it said here, don't worry too much about when to use storage or memory, but remember that by default, state variables, which are declared outside of functions, will be storage by default and written permanently to the blockchain, while variables declared inside functions are memory, just like RAM, and will disappear when the function call ends. As long as you guys understand that, in the next lessons, we'll figure out when to use which one. That was it for this. Make sure to share, like, and subscribe if you found this helpful. I'll see you guys in the next video.